And top of the morning to you, to everyone out there, and to my gurgly stomach, which has just, maybe it's because my breakfast so far this morning has been that. And my stomach is not so happy about it. It wants actual real food in there. Sadly, it looks like the gateway, I'm still getting the gateway error on the TTS. So no TTS today, which means no automated membership list for me to just read through. Before I get to that, I acknowledge the traditional owners of this land, the Whadjuk Noongar peoples. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Welcome everybody. Good morning to Henrik, RJ. RJ says greetings from Canada. I don't think I recognize the RJ name in the chat. Good morning to Crispian, Michael Wires, in Wires We Trust. I've got, so last week during a live stream, Stuart from the sawmill over the road walked in, and he is now phoning me. Good morning to, who else is here? John Whips, Scott Miller, some call it fun, Gerald42, Lionel Maisels is here, yes, and Lionel, I know I owe you a reply to your email. In a moment I will tell some painful stories of what my week has been like. Yes, good morning to Stephen George, Eddie Mills, Immy, Johnny Bergdahl, good today nerd. Tech Nebulous, did I say hello to Tech Nebulous? Gavin, good morning Gavin. Mike Carden, birthday weekend stream, yes, thanks Mike. Hang on, wasn't it? I saw, okay, so there are multiple Cardens in my life. Is it you who had a birthday just a couple of days ago as well? I saw a post from one of the Cardens about yes, doing things for the first time at a certain age. I won't mention too much just in case, because I don't want to dox. Yep, that was you. Okay, cool, Mike. Mitch, good morning, Mitch. And Johnny Bergdahl, my hot Swedish friend, has just gifted 5 memberships, so thank you very much. They went out to a few people. Good morning to David Kaiser, to Simon. Grant is here as well, Grant Maisels. David C. Okay, so, yes. In the chat, so Lionel is in the chat, and I have been owing Lionel a follow-up to an email probably from a week ago. Feels, yeah. Okay, so this is how my week went. I'll just tell you about one particular day. I had, during the week, I spent most of the week frantically building boards and flashing them, testing them, conformal coding, all of that sort of thing. For a client, this is for the truck curtain project, who was coming over at 3 p.m. on Thursday to pick them up. So I was working all day, all night, not literally all night, but I was doing basically double hours. Like it was a 80 to 90 hour week, something like that. And so it got to Thursday morning, and that was the final crunch day where I had to get as much done as possible for 3 p.m. Thursday. And I got a message at 7:30 on Thursday morning from a client saying, I am in France. I need you to build me 2 boards in the next couple of hours. I have a staff member coming around to pick them up. He's going to get on an aeroplane and fly to Germany and meet me with them there. Okay. So, yeah, so I said, that's not possible. It is in the realm of impossible. Oh, and on top of all of that, I had planned, because I knew I had a meeting with another client yesterday morning and I had to prepare a whole lot of boards for them. So my plan was crunch up until 3 p.m. on the truck curtain project and then work the rest of the day and through the night, Thursday night, so that I'd be ready for Friday morning. And then I had this landed on me 7:30 a.m. Thursday. So then I said, I can't do it. Like, I've got this 3 p.m. deadline. I am jammed until 3 p.m. I cannot build boards for you in the next 2 hours. And somehow a flight got booked anyway, but for later that night. So I ended up building 2 boards during the day, and minutes after I got them finished, my client staff member came to the door, picked them up, on his way literally to the airport to fly them to Germany. So, and then after he left, I just continued on building the other things that I had already committed to doing that day. Oh, and, okay, so that was kind of chaos enough. I forgot to mention, at about 10 a.m. that same day, so Thursday morning, there was a major internet NBN outage for like this whole area. And it was a bad one. They had to actually excavate part of a road to repair some optic fiber or something. So all through all of this, I had no internet for 2 days. It came back Friday night. I got internet back again. Crispian says, it made your beard go white, Jono. Yes. I have gone into Father Christmas mode. So, Lionel, this is my public apology to you for not following up with with an arrangement. So I will do it. But I am, yeah. Stephen says, you need a 5G backup for your router. Yeah, I do. I actually do have a couple of 4G dongles, but what I need is a 5G connection with Ethernet on it, because then I can plug it into the firewall. I've got the Unify Security Gateway Pro, USG Pro, one of the editions of that anyway in the rack, which does, I believe, support multiple upstream links and link weighting and failover and all of those good things. Yeah, the Swiss cheese model of of security, as Crispian said. Yeah, bus replacement service for the outage. Bus, as in putting SD cards on a bus, as a good way of moving data. Who else is here? Oh, Gerald42. Thank you for the coffee, Gerald. I really wish we had the TTS running so that we could get the funky audio. I'm just going to open that tab again. No, it still says bad gateway. Every now and then I load it in the hopes that it's just going to miraculously work again. Austin just tried to use the TTS. Did you see the GitHub updates on the Testomatic breakouts? No, I didn't. Crispian says, I don't reckon one coffee will cut it. Well, this, according to this coffee right here that I grabbed at the servo on the way in, according to what it says on the bottom, what size is it? Let's find out. So maybe that will cut it. A Swiss Army router, yeah. Michael says, good ISPs will supply routers that can do 4G, 5G failover. Yeah, the router I'm using is the Unify Security Gateway, which does have multiple upstream connections, but I need the 5G thing to plug into it. Some call it fun. Thank you for that Rickroll. Andrew says, fingers crossed that sending boards to Germany urgently will lead to more work. Yeah, I already have too much. Too much. I am Actually, on that subject, so I'm going to open a folder. Where are we? I need to open that, and I'm going to bring this stuff up where you can see it. Camera uploads, and I'm going to selectively open a few things. Because one of the things I have just been working on is guides and where are we? I'm going to open that, and all right, I'm going to bring this up so you can see it while I'm finding other things. This is the view of the cleanish room at the moment. I took this photo just 15 minutes ago or so. I'm rearranging all the workbenches. I think I may have mentioned this previously because things kind of got backwards since we rotated the production line. All the machines go or the other way. John Whips, thank you very much. More caffeine. Very nice. SK Photo Guy, welcome. Michael says, I have the ISP supplied one as an outer firewall and my Unify inside that. That is a really good idea. Now, when I signed up for the connection here, I'm going through Aussie Broadband. It is a crappy connection. It's a 100/40, I think, but it's old rotten copper coming into the building. It is, it's on a bundle of cable with a bunch of pairs in it, and half the pairs don't work at all, and it's very marginal. I know I've had problems in the past with all sorts of things. I wish I could get fiber into the building, but I don't. SK Photo Guy says, how's everyone at this time of day? Awesome. Always awesome. So what I've been doing, so when I signed up for, petrified copper. When I signed up for the connection, I opted out of paying for the router because I knew that I was going to be using a Unify router. Michael says, Aussie doing free upgrades to fibre at the moment if available. Yeah, I don't think there's any fibre in the street here. This is like a 1970s, 80s era industrial zone with very broken down infrastructure. It's not exactly up to the it's not exactly up to modern standards, as modern as Australian internet standards can be. Now, the point is, you can see there are some PCB trays, and you can see there's like a yellow strip along the front there. This is the new area that I'm setting up as an assembly bench. You can't really quite see it in that photo. I'm going to find a different photo. What about this one? Oh, this is just looking the other direction, a more overall view. There is still a fair bit of stuff to move. So what I have been doing is, since I got the bamboo printer 10 days ago, 2 weeks ago, whenever it is, that printer, the only time that printer has stopped is if it finishes a job during the night and I'm not here to clear the bed and load another one. So I've been printing so many things. I just wish I had another one. What I want is an H2D. So these are PCB trays for all the different parts of the process. And you can see there's a blue tray sort of out of focus there at the background. The blue ones are assembled, so there is a sequence. In fact, I'm going to find something. Back to Dropbox. I'm going to find something because what I've been trying to do is actually formalize the process. And this will also help explain a little to Lionel about the situation I'm in. And I know the rest of you have no idea what I'm referring to there, but where are we? Superhouse. Quality. Here we go. So what I'm trying to do is put in place some this one. Yes. I've been trying to organize the room a bit better and have a process for what happens. And then we got this. So I've got this. And let's zoom in. It's really only one long line, but I couldn't make it fit on one line, so it loops back on itself. And this is the sort of thing that, when I started doing this, all right, what I had in my head was, I want to define the stages of production that you go through to manufacture a circuit, like a completed assembled circuit board. And I thought, oh yeah, it'll be like 4 boxes just with direct arrows between them. And then I started putting it together and I realized there are actually more steps involved. So solder paste application goes into pick and place, and these things can be broken down as well. For example, the solder paste process involves things like stencil cleaning. Like, there are a whole lot of subtasks within each of these boxes. Pick and place machine, to do that you've got to load the job, configure it, set up the feeders, etc. All sorts of subtasks there. So this is just the high level overview of what happens if you have a bare PCB and you want it populated and shipped out the door. Solder paste goes on, it goes into pick and place. Then you have to do manual placements typically. So sitting there putting things like parts that you don't have mounted in feeders, oddball things that might be specific to that project. So that's just done sitting there with a pair of tweezers and a microscope or whatever. And then it goes into the reflow oven. And then it goes, in this case, I've got a thing, the state is called reflowed. So these colored boxes are states. You can think of it kind of like a state machine. So after it comes out of the reflow oven, it goes into the reflowed state. And that means that all of the surface mount parts are on the board, it's been soldered, like everything is fixed in place. But then it still needs to have a visual inspection, and it needs to have through-hole parts added to it, or any hand soldering that needs to be done. So manual assembly then follows an inspection, that's a step, and then it goes into a state called assembled. So the board is assembled, but it has not yet been tested, it doesn't have firmware on it, whatever else needs to be done. And then, so it goes into firmware and testing. The outcome of firmware and testing is either going to be a green passed or a red failed state. Now, if it's green passed, it's following the golden path and it goes into packaging, then it goes into storage, so it sits on a shelf or something, on a rack. So packaging might involve putting it into an anti-static bag, or, and then putting that in a box, or whatever is involved. Packaging, storage, and then dispatch. So when it needs to actually go out to somewhere, it gets packed and shipped out. If it fails testing, it needs to go to rework, and then it loops back into the assembled state, and then it can go through firmware and testing again. And the thing is that this little loop back process can be very tight. It can be immediate, or it can be a batch process where boards can be reworked and then sent back, and you can have a whole tray of boards that can be queued up that have been reworked and they are ready to come back through testing again. And I'm kind of tossing up in my head whether to give that a different state. For example, they go, and yes, there was an observation somewhere, someone said, Andrew said the colors match the trays. Yes. So I'm trying to decide whether, when a board fails testing, goes through rework, and then it comes back to the assembled state ready for testing again, should there be some differentiation that says this board has been reworked and therefore more attention should be paid to it? Or does it just go into the assembled state like all of the other boards and just get regular, like standard testing, which is my inclination. I think the idea is that all boards should have the same level of care and testing when they're at this stage. So I don't think there's a lot of point singling out boards that have been reworked. I think they should be tested just as carefully, and all other boards should be tested just as carefully as those. Scott says you need some purple trays. Are you thinking about for that reworked stage? I was thinking orange, because it goes red, red when it's failed, and then when it's been reworked but not yet tested again, it could be in orange. Should have some sort of identification, even if it is documented, says Tech Nebulous. Yeah, that could be tracked based on the serial number, because each of the boards have serial numbers on them, either as a QR code or as a barcode. The difference is some... I really didn't know I was going to be talking about this. This is kind of getting into the whole manufacturing process, which I don't know if people are interested in. But anyway, it's what is on my mind at the moment. This is the headspace I've been in, is optimizing this process. So that's what that's what I'm going to talk about. Oh, Gerald says it is very interesting. Okay, thank you. So the boards that I assemble all get barcoded after they come out of reflow. And they get barcoded at this manual assembly and inspection process. And the reason they actually don't get done sooner is that the stickers that go on them, if they go through reflow, they kind of shrink a little bit and deform slightly. They do kind of hold their, they're mostly okay, but you can tell that they have been overheated. So we put the stickers on each board after they come out of reflow. So at this stage, when they're at the manual assembly, there are a whole lot of stickers that are put on, which are done with the Brother industrial label material, the high strength labels that are chemical resistant and things. They're like permanent labels that'll last out in UV and bad conditions. They're really good labels, and they do actually survive reflow, but yeah, you can tell they've been through it, and I want them to look perfect. So they get barcoded at this point. For clients, for some of my clients, they don't want any traceability back to me. They want the board going to their end customer, and they're okay with there being a serial number on it, but they don't want there to be a URL that points back to me. So in those cases, what I do is use just basic barcodes. They're very simple. And for others, or wherever possible, I use little stickers which are QR codes, which have the URL back to the Superlab portal, which with the serial number of the board. So if you click on the link, it takes you to the profile of that board with its production history. And when stuff is done here, like if boards are reworked, that could be recorded against the ID of the board. Pete, you're saying my face is a basic barcode. There's nothing basic about my face. It's a barcode, but it's not basic. Andrew says, if rework is needed, can you put a temporary label on using a tag? Yeah, I could. But what I have instead is... So you can see here, we're going left to right. So we go reflow oven to reflowed is this golden yellow, and then blue once they're assembled, and then red and green. And as was pointed out earlier, and you can see the benches, the colors here. So manual assembly, it can be a little confusing matching the state against the location, but I think this kind of works. So boards come out of reflow and they are in a state of reflowed, and they go to the manual assembly bench, which is yellow. So the yellow reflowed boards go to the yellow bench. And then after assembly, they end up in a state of assembled, which is blue, and then they go to the testing bench. So all of the blue boards go to the testing bench. So it sounds really confusing because you'd think, oh, this first one should be the blue bench because that's where the assembly happens, and then they end up assembled. But it's the colors are sort of based on the destination. It is where should the board in this state go. And the boards that are assembled, which are blue, need to go to testing. So the color signifies the destination. And then from testing, it can either go red or green, depending on whether it passes or fails. So if it's red, it moves across to rework and then back again for more testing. Or if it passes, it goes to packaging. So I need to rearrange down around this part of the area here. I've got KO3 in storage here, which is taking up a lot of space that I really can't afford. There's a feeder cart here. I need shelving in here, racks. I need to move all of the stencils down to this corner. I need storage racks for completed boards. I just don't have room for that at the moment. But after more conversations with Lachlan during the week, this wall on the right here, which is the east wall, looking at this orientation, north is straight up. So this is the east wall. There is another 4.5 meter space directly behind this wall, which I might be about to take over. So that wall might disappear, or at least part of that wall might disappear, and then we'll get a whole extra space to the right, which would help tremendously. So looking at those colors, yes, you can see here, printed trays. These are ones that have reflowed. The blue ones you can see are assembled, red is failed, etc. And then yesterday I did this. So now there are laser cut trays that hold the trays, laser cut dispensers for the trays. I've got 60mm and 80mm trays at the moment. I've also designed 100mm trays, but I can't print them because the printer's not big enough, which is another reason to get an H2D. The print bed on the X1C is just a bit too small. I have to print these ones diagonally and they just fit. They only barely fit. So if I went to 100mm width trays as well, which I do need, and in fact I need 120mm wide trays for some products, I just can't print them on an X1C. I'd need an H2D for that, or some other similarly large printer. So there is that. Where's another example? No, not that one. I'm looking for a different photo. Where did it go? Oh, is this it? No. Here? No. Oh, it's relevant anyway. So this is the assembled trays. These are spare trays ready for us for the boards that have been assembled. So what you're looking at right here is which bench you're looking at. I've just got to find it. Find the right photo. Okay, no, not that one. Where did it go? Did Dropbox not upload my pictures? Yeah, oh well. Anyway, you can tell from this one. So this is the yellow bench. So boards that you can see up here, there are boards that have been reflowed but still need their headers and things soldered on. So they come in yellow out of reflow onto the yellow bench, which is the assembly bench, and then when they are assembled they go into blue trays. So this is the storage of spare blue trays, which is the assembled trays, and then when they're assembled they move one step to the right. You can see there are assembled boards up here, so these are customer boards, and they go to the blue bench, which is the testing bench, and you can see Testomatic there, and like a test breakout, a test module there. The little cardboard box, which is my light box at the moment, because we take a photo of every single board, which includes capturing the barcode so it gets automatically processed to be associated with the record. And then from there, from testing, it goes across to the next bench, which is rework if it's failed, or it goes into a green tray, and you can see there are green and red trays there. what I'm looking for, and I don't know where has this photo gone? I took a photo, at least I thought I took a photo. Oh, here it is. Here it is. So I did I also did a laser cut tray for the testing bench, which has both green and red trays in it. So you can just grab whichever tray is appropriate. So typically, as you're testing boards, you'll have two trays. You'll have a pass tray and a fail tray, and then you test boards and you put them into the appropriate tray. And from there, the red trays move to rework, the green trays move to packaging. In fact, to pre-packaging, because there is a whole extra part of the process, because we might have to do things like, you might have a board that is fully assembled, but now it needs conformal coating. And so that is a step that is not even in this flowchart. There should be, so after passed and before packaging, there should be a branch coming out here, which is a detour through conformal coating and baking of the coating before it goes into packaging. So part of what has been going on over the last little while is figuring out how to deal with increased demand, because the reality is I just can't keep up. I am, as you can tell from that story I told earlier, my brain is constantly in a state of just being fried, and I am overcommitting and failing to deliver because I can't do all of the things. So some call it fun. I've missed a bunch of chat, so I'm going to work kind of backwards through the chat. Do the trays have a static electricity discharge risk? That is an excellent question, and hang on, I'm going to find DGT anti. So you can get special 3D printer filament, which is ESD safe, like it's static dissipative, etc. Hang on, I've got to cough and take a drink. And I did not use that. I just used PLA. And one of the reasons for that is that PLA is a little porous. It takes on moisture. So my plan is to spray them with this stuff. So this is a like a static dissipative spray, and pretty much, so this stuff can be used to clean surfaces, and you can also spray it and let it dry. And there are other sprays and things as well. And then Michael says cough then coffee, yeah. So the yeah, according to the data sheet of this, in fact, let's pull up the data sheet. Where's zoomage? There's some zoomage. Yeah, fast drying anti-static coating, eliminate static charge, reduces turboelectric generation from flexible surfaces. So it's not a perfect solution. Haha, that was unintentional. Because you can't just spray something on a surface and go, oh, it's all safe now, because you've got to have like a discharge path for any buildup that might occur on the surface, and etc. So there are other things that I'll probably need to do, like put a grounding strap in the tray holders so that nothing gets built up on it. Because those laser cut holders that I made, these ones here, that's just laser cut acrylic, and that's going to build up static for sure. So I need a way of dissipating any static that might build up on these trays. And because PLA is hygroscopic, if I spray the if I spray them with something like this, it will tend to be absorbed into it. In fact, what I could probably do is put the trays in the dehydrator. Like, I could bake them so that they are really dry, which means that they would then be thirsty. And then if I spray them with something like a static discharge material, it'll soak into the PLA a bit. Jack's Tech said, just a strip of copper tape will work. Yeah, just something that the trays can sit on or rest up against to make sure that no charge builds up. Yes, so that is my tray. That is that is a very valid question. I considered using static dissipative printing material, like material to print the trays out of. And I came to the conclusion that would be hard to do and get all of the colors and things that I want. And so I just decided that what I would do is use regular PLA, coat it with zero charge, and let it soak in so that they are well impregnated with it. And hopefully that will alleviate anything. So you can see there's a static dissipative mat. This is quite a few years ago now, I bought a very big roll of static dissipative material, and this is a piece cut out of it. It's the same thing as I've got on my workbenches here. And there you can see there's another piece down there. Those are, and I've got a big table in the cleanish room which is covered, in fact 2 tables that are covered with it as well. And there is a clip. Oh, you can just barely see it. You see there, just in there, that is a clip that goes onto the static dissipative surface. That's a grounding clip. One thing you might notice is, see, we've got this earth strap here. And you see that yellow cable bundle? That is the earth strap from this grounding point, just done up with a cable tie and going nowhere. So right now, this wrist strap does absolutely nothing. It's not connected. So when I set this bench up, in fact right now, as you see this photo, this soldering iron doesn't even have power connected to it. There's no power to that nozzle tip cleaner, because I have just, like in the last day or two, been in the process of moving stuff around. So I just grabbed that soldering iron off the bench that was down the back, moved it to this location. So I'm just shuffling things around right now. Things aren't even plugged in. So that is, that is the state it's in. It's all in progress. But if you ignore these yellow trays on the left, because these really should be stored with the reflow oven, this basically shows how things work. So the yellow bench has yellow trays arriving, which are boards that have been reflowed. They get worked on, parts and things are put on. They then go into blue trays to show they've been assembled. And the assembled boards then move to the right and end up here in a queue, ready to be tested at the blue bench. So then blue goes to, the output of the blue bench is either green or red, and if it's red, it goes to the red bench. If it's green, it goes to the green pre-packing sort of bench. And other things in there. This is a client thing, but it's not revealing too much information. You're not going to glean any competitive advantage out of this, so it's okay. You can see an assembly guide just here. So this is on the assembly bench. So it's the yellow bench where things end up going into a blue tray. And this is the manual assembly guide. This is a photo of the top side of a PCB. This is a client's board, and it is showing all of the parts that get added manually. So these are the parts that are soldered on by hand. Down on the left, I'm not going to zoom in massively on this because it is a client board and I don't want to reveal too much. This doesn't show you enough to know anything about it, so it's okay. On the left part of it just here, there is a table which lists all of the parts that go onto this board. So it'll say quantity 2 3.81 millimeter two-way pluggable sockets, 1 3.81 millimeter three-way pluggable socket, you know, that sort of thing. So it lists the parts that you need to complete that board in a table format. And then it shows it shows a board with all of those parts installed and highlighted locations with a label saying what each one is. So if you are sitting down to assemble that board, you have the board and the guide in front of you that shows all of the parts that go on the board. So by the time you have finished that board, it should look like the photo that you've got in front of you with all of those parts. And I have, John says, it's a work in progress with no work in progress. Yeah, there is actually a lot of work in progress on this. If we go back to where was that photo? Where was that photo? Oh yeah, there's one. Oh, actually, this is a different view. It shows you some failures. So here are some red trays with boards on them that have failed testing, which are waiting at the red bench to get reworked. Up there you can see a whole lot of blue boards. Those ones are work in progress. Where does this show it? That one. Yeah, this kind of shows it. So boards that are works in progress, you can see all of these blue ones up here. There are, how many are there? There are 8. So there are 32, oh, minus 1, there are 31 of that board sitting, and then there are a couple of trays there you can see to the right of a different type of board for a different client. So these are customer boards. In fact, on this, I don't know if I can zoom in any further. Can I zoom? Oh, my trackpad's just gone flat, maybe. Oh no, there it goes. You can see on there, that is the QR code, just on there. Each of those boards has a QR code on it, which is the serial for that board. And you can see the label printer down there. So that's the Brother label printer that does those industrial labels. Oh, the other thing I need to add to here is I've got to put fume extraction in. There's no fume extraction at this bench yet. Up until like 2 days ago, this bench is where we did the solder paste. And that's why all the stencils are up here. So all of these stencils that you can see, all those stencils, you can just see the ends of them sitting up on the shelf. Oh, and also these plastic tubs, these are for storing bare PCBs before they get solder paste on them. These are IP68 rated, or whatever the terminology is. They're basically airtight, watertight containers with the with bare PCB stored in them, and they're categorized by client and project and things, with desiccant in them. So they're keeping the boards all clean and dry and untarnished until they are ready to be used. And then the stencils are on the shelf above. All of this, everything, all of those stencils, all of that board storage, that all needs to be relocated to the other end of the room. That's a future job. Haven't got to that yet. So it's all very much in progress. So I mean, it's one of these situations where I am trying to make the process more efficient and well documented, while also frantically trying to run the process. So building things, designing things, meeting customer obligations, while simultaneously making it more efficient for future work. And also, a critical part of that is making it possible to bring other people in to help. And that is a major issue. So over the last couple of weeks, I've had quite a number of people who have seen the state that I've been in offer to come and help. I've had probably 6 people, like with really really serious offers. If I said to them yes, they would turn up here and spend days doing random whatever I said they needed to do. So they're like genuine, valid offers of help. But the problem is, when you're in the middle of chaos, bringing extra people in to help just makes it worse, because you can't hand off tasks cleanly, and yeah, it becomes a situation where it takes longer to show someone what needs to be done than to just do it. Now the thing is, just doing it yourself solves it that one time, but it does not set you up for being able to repeat that process and remove the dependency on me as the person who can do it. So that is really why I am spending so much time, so much of my extra brain cycles thinking about things like this and making assembly guides. Like, can you see it in that photo? No, you can't. Back to got to find the right photo. Yeah, and doing things like guides like this. So in fact, on the right here, you can see the old assembly. I've been doing assembly guides for years now, actually. And the way I started doing them was that I would print out of first Eagle and then now Fusion or whatever, it could be KiCad. I would print a board layout, and I would just go on over it with a highlighter and mark all of the parts that need to be put on. And you can see a perfect example of that up on the right hand side. And then I just put them into those plastic document wallet things so that they can float around on the bench and be safe. So you can see on the right there, what board is that? Oh, and you can see handwritten notes and things. So this is how I used to do assembly guides. And it's a really quick and easy way to do it. It's remarkably easy, because all you do is you open your board design, you turn off all the layers you don't care about, just leave the top layer and the pads, and hit print. Like, scale it to maximize fitting it on the page. You print it out, and then you just grab a highlighter and go, oh, I need that connector, and we've got to put this through hole bolt cap on, or whatever it is. Handwrite some notes on it, and in a few minutes you're done. You've got yourself an assembly guide. That is 1,000 times better than having no assembly guide at all. It gets you a very long way, and it's really useful. So that has definitely helped when I've had, like in the early days when Tom was helping and before he had as much experience, these assembly guides were useful. When Amelia helps, these assembly guides are useful. But more recently, I've been going to more trouble and doing assembly guides like these, like the one that you see there for that client board with a photo. So as we're assembling the first couple of boards, we take photos of the boards at each stage of assembly, and then they get pulled in. This is all done in Keynote. So they get pulled into Keynote and marked up and then printed. And then you've got a versioned, and then if we do a new version of the PCB and things change, you can just duplicate that slide, pull in a new photo, make adjustments as necessary. So we end up with versioned assembly guides. And I actually showed these to a client on Friday. I went over to have a meeting with a client, and just before leaving to go over there, and also you can see here, this is the manual assembly guide for this particular product. For the exact same product, I also have a conformal coating guide, which shows all the masking locations. I have a pre-packing guide, which shows all of the headers and things that need to be plugged in. I have one that shows the location of glue, because this particular board goes into a very nasty industrial environment. It gets conformal coated, and I put Loctite Extreme Gel on a whole lot of the parts, like on some of the headers. There's an inductor on the board which is kind of heavy, on the bulk capacitors, they all get glued with this gel glue. So I've got a guide that shows the locations to put the glue on the board. So for each of the steps of production of this board, we have a guide like this, but it's specific to that step. And on Friday, when I was having that meeting with a client, I went over to see them. Before heading out, I grabbed all of the guides relevant to one of their boards, like for all the different stages, just to show them. And they thought it was really cool. Like they were very impressed that I'd gone to the trouble of actually documenting all of this in such a thorough way. And in fact, their production manager, who was there in the meeting with me, asked if I could send him the final guide, like the pre-packing guide that I have. He wanted me to send him the pre-packing guides for all of the products I make for him, so that he could put them in on his factory floor and use that as a reference, because that way they know when a board arrives from me and it goes onto their factory floor and it's got to be built into their product, they've got a picture of what it should be. And if there is any discrepancy, like there is a connector missing or something like that, they have a reference guide. So it becomes part of their quality system as well for the intake of the boards into their manufacturing process. So yeah, it hadn't even occurred to me until he said that on Friday that my customers would be interested in having copies of the pre-packing assembly guides. So yeah, that's kind of a cool thing. Scott says, sounds like a board that very nearly needs to be potted. It's yeah, kinda. It has a whole lot of mechanical bracing. This particular board goes inside an enclosure. It gets conformal coated and glued, and then it goes inside an enclosure which is also IP68 rated, and it's got these automotive connectors on it. See this DC1312PA connector, this big grey thing down the bottom. This has got a triple gasket seal on it. So effectively, like if you plug the connector into that, effectively it's waterproof. These go into nasty environments. But there are always trade-offs. For example, you see that blue thing there? That's dip switches. How do you make dip switches impervious to bad stuff? You can't. It's just impossible. So those are one of the things that we mask off. And the dip switches do not get conformal coated because you need to be able to move them. And they have contacts inside them. They are physical mechanical switches. So the switches slide, they make and break contacts. There is the possibility for corrosion in those contacts. But yeah, it's all a matter of minimizing the potential problems. And also there's a big relay, there's a 40 amp automotive relay that goes into a socket just here. So that thing right there is for a 40 amp automotive relay, and that's got contacts, so that gets masked off when it's conformal coated, because you need to be able to plug the relay in and have it make contact. Scott says, dip switches aren't even impervious to a good environment. Yeah, I know. It's a trade-off. It's a trade-off. It's one of those things where the client wanted it to be done this way. The first version of this didn't have the dip switches, and David says, what kind of a dip put switches directly on a board that needs to be conformal coated? Yeah, that's right. The options for configuration of this board are handled, they can be configured in firmware, and you can plug a programmer into this open it up with a console, with a laptop or something, and you can change configurations, change options. That was how the first versions of this board worked. And the problem was that these needed to be reconfigured by someone in the field with nothing more than a screwdriver. So this was the solution the client wanted. In fact, it wasn't even my client, it was my client's client who wanted this. So I am several steps removed from the end result. This is a really good question. RJ said, aren't there any magnetic type dip switches that could be IP68? Yeah, you absolutely could make something that is functionally equivalent to a dip switch with magnets and like hall sensors or something. Rubber covered dip switches, says John. Maybe. Yes. Okay. I'm just scrolling back through through comments. Mitch said, the ideal time to take a scaling hit was yesterday. Next best is today, because if you don't do it, what about tomorrow? Right. That's right. Okay, I am scrolling way back in the chat. Oh, and Cassio is here as well. So other people who joined the chat. Pete, other people who joined the chat since I started. David says, just slowly start moving that east wall out, little centimetre by centimetre. Lachlan won't notice a thing if you do it over a period of time. Is that like when you've got a big jar of cookies and you'll eat one cookie per day and the level slowly goes down and you just hope that nobody will notice until there's one cookie left, and then you don't take the last cookie because then it's obvious the jar is empty. Yes, David asked, is KO a pick and place machine? Yes, it is. So on this, starting from the bottom right, solder paste goes on, it goes into the first pick and place machine. Right now, this bit in the middle, that bit right there is a conveyor. That conveyor does exist, but right now it is actually sitting on the bench just here because it hasn't been mounted between the two machines. But one of the next steps is to mount it between the two machines so that the boards will pass on the conveyor straight through KO1 and then the transit conveyor through KO2 and then out another conveyor here to the manual placement area and then continue on the conveyor into the reflow oven. And then from out of reflow, they go to manual assembly. Oh yeah, Scott says, next rabbit hole for John, color-coded anti-static mat for the benches. Yeah, no, I think it's enough just to have the color strip along the front of each bench. Then where are we? Andrew asked, can you contract out some of the improvements you want, like the conveyor system? Maybe. Oh, Jacksek says, I meant down the center of the tray. So that as boards go in, they contact the strip of copper. That's an interesting idea. It wouldn't, yeah, okay, I'm gonna have to think about that. It could go down and then underneath. Yeah, anyway, I will consider those things. Paul asked, good morning, can the QR code hold the MAC address for ESP32s? It can, but okay, with QR codes there is a trade-off. The more you store in them, the bigger they get. And the bigger they get, the harder it is to shrink them down. The standard QR codes that I use, where is one? There is bound to be a board here somewhere with one of these QR codes. Oh, here's one. Here is one. I'm going to switch to... Is the overhead camera turned on? Yes, I'm going to go full zoom. I'll get this focused and then switch over to it. And Come on, exit. All right, so I'm not going to show you the whole board. This is also a customer board that I'm going to switch to. Oh, I'm going to turn that on and switch to overhead camera. That one. Okay. This is an example of the QR code that is on a board, and it's got the human readable serial number. So this is board 4047, which means it was made, we're currently up to about 4,600 or just under 4,600. So this board was made about a month ago, I think. It would have been assembled somewhere in that region. And the QR code, in fact, if you point your phone or do whatever with the stream right now, you can probably extract a URL from that. And if you go to it, you'll discover that it's not working because the portal system, the dashboard system, is not running right now. But it will go to a URL which is something like d-superlab.au/4047, because 4047 is the serial number for this particular board. And then if that system was up and running and you were authenticated, so you're allowed to log in, and that serial number was associated with a product that you as a user are allowed to see, you could then see the production history of that board. So Paul's question was, could the QR code embody the MAC address of the ESP? Yes, but then it would get a whole lot bigger. And also there are many projects that I do that don't have ESPs in them. And in this particular case, it has two ESPs. So at this end of the board, you can see this is the ESP32 S3 Vroom module. Other end of this same board, there is an ESP32 H2 module, because this particular product uses thread wireless networking. And there is firmware running in this microcontroller which handles the thread mesh net. And this is what runs the firmware for the high level control of the product. And it communicates via serial to the H2, which handles the mesh networking. So there's a MAC address for that one. There is also, in terms of the mesh, the MAC that matters is the one that's in this one, in the H2, because that's what it uses to bring up, to identify itself when it brings up the thread mesh. What's this? Yeah, I was just going to say, what's the subject for today? But the subject for today is what has been on my mind, this process improvement stuff, trying to make it so that I am not doing I'm doing in excess of 80 hours every single week. And I can't keep doing this. I need to be able to scale what I do and bring on people to help with different stages of this. Because the thing is that, okay, look at this diagram. There could be a person here doing manual assembly, another person here doing testing, another person here doing rework, another person doing packaging and conformal coding. There could be a person doing dispatch. Could be a person plus a person actually putting on solder paste and running pick and place machines. This whole thing could be scaled by adding people. But the problem is I need to be able to pay the people and I need enough of a process that the people have something defined to do. And at the moment what is happening is that we've got these dedicated areas set up for different purposes, and Tom and I just run around between the different areas. So Tom will put solder paste on boards and run the pick and place machines, and then when that's happened, he will put parts on them, and then he will put them through reflow, and then after they've been through reflow, he will solder connectors on, and then after that he will go here and he will flash them and test them. It's one person running between all of the different stations. Each station has its own particular purpose, but it's one person who is doing the circuit of all of these things. I need to be able to add more people to those different parts, and then throughput could go up dramatically. But yeah, this is the pain of scaling, is trying to figure out how to afford to pay people and having productive tasks and roles that they could undertake. Pete said, oh, hang on. Scott says, some time ago I came across a potting compound that you could actually poke a tool through and access dip switches. Want to try it sometime? Ooh, that seems interesting. Yeah, now that I'm thinking about this, another option would be some kind of a cover that you take off. So like it could be maybe 3D printed out of TPU. So it'd be like a soft rubber cover that goes over the dip switches, and it's left in place normally. And if you want to change the settings, you pull the cover off, flip the switches and put the cover back on. It's one option. It'd have to seal nicely against the PCB though, so I don't know how effective that would be. Jackstack said, ooh, high volume, low mix levels. What is that about? Am I screwing up my microphone somehow? I don't know. Graham asked, at the risk of launching a squirrel chase, could the dip switch be protected by a cut balloon to prevent dust, dirt, and water ingress? Cut balloon, yeah, that's. I think that's a similar sort of idea to what I was talking about. Some kind of a cover that goes over it. Scott says, I always make sure to take the last cookie, then leave the jar in the middle of the counter with the lid off. That way, the cookie fairy, Mum, sees it and makes more. Yeah. Where are we? Where are we? Crispian says, Jono has been reworking the workflow in his cleanish room whilst rushing to get multiple jobs done and needs a reflow oven to fix his assembled thoughts. Yeah, my thoughts are all, as John Whip said, chaos theory. Stephen says we still have another hour to work out the topic for today. Squirrel / rabbit crossbreeding, Scott. Paul says, so Paul Schultz, who was the one who asked earlier about putting the MAC address on the thingamajigamy, says, thank you, I'll probably need to have a similar portal set up. Ah, really? Well, do I have a bridge to sell you? So this ties into Testomatic. So that portal link, which is currently not active, is to the portal system that Mitch has been working on. And the idea is that it should all be open source so that anybody else who wants to do their own installation can do the same thing. It's at the moment it is very much WIP. It is a work in progress, and so it would not really be suitable for you to grab it and start using it, but that is the goal. So what Mitch has been working on is this portal system or dashboard system for managing information about devices, so that you can record parts of the production process, add notes about it, like when it was shipped, test results, all of those sorts of things which come in from the Testomatic. So it's basically the software side of the Testomatic. So the Testomatic has the physical box, which is the thing that you plug your board into to load firmware and do the tests. And then there is the software that runs on the Testomatic to do that, to do the firmware loading and the testing. But that information needs to go somewhere. It needs to be stored indefinitely, and it shouldn't be stuck on the test jig. It needs to go into some central location. And also you might have multiple test jigs. You might, in a factory, you might have 20 test jigs. And so as you're testing boards, the test results of all of those boards need to be pushed somewhere for storage. That is the portal that, that Mitch is working on. So it has a database that stores all of the information that is accumulated from all of those different sources. The sources could be test jigs that you've got. It could also be manually entered information, such as this was shipped on this date via TNT and here's the tracking number. Or it could be this board was reworked on this date and here is a photo of the rework. Or it could be this board got destroyed by this calamity, like it was in a device that was in a car that crashed, or whatever it happens to be. So yeah, anyway, it is something that, it's a system that I want for myself and that other people may be able to benefit from, make use of. So, yes, Paul, if you're interested in a similar thing, and if there are other people who are interested in a similar thing, it is not quite a thing yet, but it is becoming a thing. So, we should collaborate. Jack Seck said, Jono's brain dump v3.0.mp4. That is today. Pete says, get yourself some government funded interns via RMIT. Maybe, but this is the part of the problem that I was getting at, which is that adding interns, or doesn't have to be an intern, it could be an experienced person. Like we could be talking about a really experienced engineer. And when I said that I've had about 6 people give me serious offers to just come in and help me, a couple of them are actually very well qualified serious engineers. They are people who can build stuff, or design stuff. They know what they are doing. But the problem is that I'm not in a position where I can accept that offer because I can't hand things over to them. I'm not in that scalable state right now. So that is why I need to do all of this sort of thing. I need the process, I need defined tasks or sub-projects or whatever that can be handed over to them. And then I will be able to scale a bit more. If I brought in a bunch of interns now, or even one intern, it would make me slower. It's the, who was it, somebody Brooks? Who was it that wrote The Mythical Man Month? The Mythical Man Month. I haven't read this for a very long time. The Mythical Man Month. So here's a squirrel. Here we go. Fred Brooks, yeah. Here is a squirrel if you haven't come across this before. When was this book published? 1975. Okay, so I bet right now on the stream there are 2 types of people. There are the people who are going, oh, never heard of this, and there are the people going, yep. So the Mythical Man Month. This isn't, as I said, it's an old book. It was published in 1975, and it's a book about software engineering. And you might think, how is that even relevant? Like, what has software engineering in 1975 got to do with software engineering in 2025? But it is about processes and principles. It's not about, oh, what is the latest hot language, that sort of thing. So, yeah, what is the concept of a Mythical Man Month? That Man Month is a hypothetical unit of work representing the work done by one person in 1 month. Brooks' law says that the possibility of measuring useful work in man months is a myth and is hence the centerpiece of the book. And I should point out that when I say man, that is because of the patriarchy, etc., etc., etc. That was just the terminology that was the terminology du jour of 1975. So it is a book of its time. And the idea was that in a lot of software or project estimation at the time, the unit of measure was man months. It was, okay, we could have 10 people working on this for a month and we'll get the job done. And therefore it's 10 months of work. And the thing is, one of the things related to this is, adding people. Here it is. What is the mythical man month adding people? This is the point that I was getting to. The key idea of the book was that adding manpower to a late software project makes it later. The idea later became known as Brooks' Law. Yes. So if you are crunched and running as hard as you can, bringing in help can make the situation worse, because what you're doing is adding overhead in being able to hand off tasks, in being able to oversee those tasks as they are being done, to assess the outcome of them. Yeah, it's the classic thing. What this was addressing back in 1975 was the classic thing of having a large engineering project with a bunch of people working on it. Say you've got a team of 100 engineers working on an operating system or something, like some major software project, and you've got an 18-month window. So your project plan says we are going to finish this job in 18 months and we've got 100 people working on it. So this is our team. And then it gets to be like month 12 and then month 13 and 14 and 15, and you're heading towards your 18-month projected completion date, and you are nowhere near done. You are running as hard as you can, and everybody is putting in extra hours and working like crazy, but you can't see you're not going to make that 18-month deadline. And then upper management or the board of directors or something says, we are going to give you more resources. Here are another 50 people to help you so that you can finish the job in time. And now instead of having 100 people on your engineering team, you now have 150 people on your engineering team. And chaos happens because the people who have come in late don't have the history of what's happened up to that point. They just act as a disruptive force. It is like a chaos engine. And then you end up with a mess. And now all of a sudden, instead of rushing to the finish line at 18 months, now you're 3 years down the track and the job is still not done, and it's all just turned to a big pile of poop. So that is the general... Okay, I was just going to say, now you don't need to read the Mythical Man Month, but yeah, you probably should read it. I have just done a very bad job of the 3-minute summary of the book. But how long? It must be, how long since I've read this book? It must be 20 years or more. I really should go back and read it again. Find it somewhere. Find it somewhere. Oh, yes. Fred Brooks, yes. Oh, Grant says, on my shelf, yes. And Mike says, people like me nodding sagely. Yep, that's right. So there were... Michael's, what was this? Michael says, a thing that will end up on John's dopamine list in about 12 months. Yep. So Paul says, allocate a process testing day and get some people in to do some work following the process. Expect nothing to get completed, but that is an excellent suggestion. That is a really, really good suggestion. So Paul's suggestion there is like, it's testing the process, testing the documentation. I have done similar things to this in the past. In fact, Andy and I have done similar things to this in the past. We did this quite some years ago with the Open Hardware Mini-Confs, because the thing is that with the Open Hardware Mini-Conf, it's a one-day event. You get a bunch of people in the room. You want them to assemble something. They've got no background in it. You give them a kit of parts and a guide, and then you hope that they can complete the job, and the helpers are running around and helping and doing their thing. But you really don't know until you get someone coming in and using your guide for the first time. You don't know how they can screw it up. They will find ways to screw it up. And so what we did a number of times was prepare whatever the project was that was going to be done. And John, who is often in the chat, I don't know if he is in the chat today, I don't think I've seen him, was involved in this as well. And I think at some point Mitch may have been. In the very early days, Mitch was doing some purchasing for parts and things for some of these mini-conf projects. And so what we would do is get people at the local hackerspace to build these things and go through the process. And the whole idea is to do a test run of what it's going to be like on the day of the conference, but do it with just a couple of people in a friendly, no pressure environment prior to it, so that you can then see, oh, we thought that they could build this in an hour and a half and it actually takes 4 hours. So, you know, these sorts of things, it's very hard to judge in advance. And it's really hard when you are the one who has designed the thing. Like if you design a kit and you have put so much time into it, you have done all of the design, you know it intimately. If you have the parts put down in front of you, you can go, I can build this in 20 minutes. Shovel the parts in, solder, clip the leads, you're done. Hey, that's it, it's finished and it works. You give the same thing to someone who has never seen it before, and 4 hours may not be enough time, because they have to look up everything. They have to figure out, where does this resistor go? This connector, like these two things look similar. Which one is which? Have I got it in the right place? Have I put it in backwards? Have I put this connector on the wrong side of the PCB? That happened. There was one mini-conf where there was a large connector. I think it was actually the Raspberry Pi connector. It was like a Pi hat, and there was a 40-pin Pi header. So you know the ones, they're 20 pins long, 2 pins wide, so it's a 40-pin connector that is all one connector that gets soldered onto the PCB. And one of the people in the mini-conf soldered the connector on the wrong side of the PCB because it fits both ways. And for whatever reason, he didn't look at the photo or something. You know, people make mistakes. It certainly wasn't his fault. He was doing the best he could and trying to figure out how all these pieces fit together. So he put the connector on the PCB, all looks good, solders it on, solders all 40 joints on. Oh no, can't put the thing on the Raspberry Pi, it doesn't fit, it's on the wrong side of the board. And then recovering from that is really, really hard. If it's in a situation where you have many people who are working in parallel on these things, you'll have people who will rush through it and will do it in 20 minutes, and other people who the multiple hours will not be enough. So Paul's suggestion about testing the process and testing the documentation is very, very important. It's also something that has been mentioned on the Open Hardware Manufacturing podcast, because Opulo, which is the company that makes the Lumen PNP, in fact, I'm going to pull this up because these guys are awesome. If you don't know about Opulo, you should. Opulo, did I get there? No. All right, I'm just going to search for Lumen. Oh, here we go. Oh hi. This is not the not what I was looking for, but it kind of is. Last commit by Theo yesterday. Okay, so OHI stands for Open Hardware Assembly Instructions. So Opulo is the company, and they make this open source pick and place machine. And they have, oh yeah, Hardware Cafe. This is a new thing. I haven't had time to really look into this yet, but this sounds like a really cool thing. Anyway, I'm not going to chase that thing right now. So open hardware assembly instructions for Opulo machines. This is where all of the process is documented. And this is used for, I'm just clicking randomly in, oh, Packout. Okay, let's have a look at Packout. So this is the documentation that Opulo uses internally as they are manufacturing these pick and place machines. Each step of the manufacturing process is documented, and they publish the documentation, including their own internal documentation, which is really cool. So this, yeah, I just randomly clicked down through to one of the endpoints in this repo, and you can see the Packout is showing, this is a document showing how to put feeders into the cardboard packaging ready to be shipped out to the customer. And it's got an instruction here: insert a spool arm above each of the 5mm feeders oriented to match the image shown below. So you can see there's a spool arm on each of those, and there's a close-up showing the spool arm sitting there. Place a thimble into a 1x1 plastic bag, so the thimbles are there, double-sided tape here, and then stick it on there, etc. Oh, there it is, right there. So, success. The feeder has been completed and is ready for further use. So this is all done in Markdown, and when they bring on a new staff member, if they have a staff member whose job is to pack feeders, they have this documentation, and the person can just go through the steps, see visually what it is they are doing with little text explanations, and they can get to the end result, and there is a picture of this is what you should have at this stage. Once you've done all these steps, you should be here. And the yeah, it's really, really nice. And what this has allowed them to do is scale their business by bringing on people to fulfill specific roles, and also to swap roles. If you have a crunch on a particular thing, you might have a staff member, and say you've got a whole heap of feeders that you need to ship out on a, and you need to move people off other jobs and get them all packing feeders. Well, now you've got a document that says this is what you need to do, so people can move sideways into other tasks. And by going through this, and this is a continuous improvement sort of loop as well. So if there is a situation where someone is given this task and they start following the guide, and the guide is not clear enough, or there is a problem or a question about it, they can just update the guide. So the guide becomes a living document which shows what needs to be done for each of those stages. RJ says, we take our knowledge for granted. Having gone through this zero knowledge build based on instructions, revising diagrams, instructions or steps, etc. will lead to excellent revised docs. Yeah. You got to test things. And that, I'm not quite sure how to put this. You have to test assumptions. You have to try things for real. What's that saying? Something like, in theory, reality and practice are the same, but in practice they're not. Something like that. Yeah, you got to do things for real. So I am very impressed by what Stephen, Lucy, and all of the others at Opulo have done with their, not just building an interesting piece of technology, that in itself is cool, but also with all of the documentation and all of the processes around it, so that they can build a business that scales. And if any of you have not got on this train yet, you need to listen to the Open Hardware Manufacturing podcast. In fact, I'm going to stick it in the chat right there. Oh, and there's another podcast which you really should. If you're interested in this stuff, you really should listen to the Pick Place podcast as well. Hang on, I'm going to find that one. Pick Place podcast. Go. This one. Which is, hang on, I'm just finding the thing. Here we go. Pick Place podcast. And I will also drop this. So this is hosted by Chris and Melissa. Chris Denny and Melissa Howell, I think it is. I'm not quite sure of the surnames. I'm going to drop that in the chat as well. Yeah, so where are we? Episodes. This is, it's kind of complementary to the Opulo, so Open Hardware Manufacturing podcast. This deals with the small scale, like little stuff, and a lot of open sourcey related things. So this is it's really targeted at people who are customers of their machine, which is the Lumen PNP, like the desktop pick and place prototyping scale sort of customer. The Pick Place podcast is produced by Worthington and Circuit Hub, and Worthington is their focus is on the bigger scale of stuff. So these look at this, conveyors, an episode you didn't know you needed. Yeah, these people do things like they run a big facility and put through thousands of boards. So they're not at the Opulo desktop scale. These are at the big production line with multiple pick and place machines on the line and multiple lines and teams of people in very high-end facilities, you know, that sort of scale. So the stuff they talk about is complementary but different to the Open Hardware Manufacturing podcast. So yeah, it's very interesting. So this is a really cool the RGB LED. Like if you scroll through the topics of the Pick Place podcast episodes, like you keep coming across things that make you think, oh yeah, that is like conveyors and where was it? Yeah, ESD flooring. So this is related, that's ESD stuff we were just talking about. Managing orders, and where was it? Yeah, RGB LED, like RGB LEDs failing in reflow. They got a whole episode about problems with RGB LEDs. Yeah, this is their most recent, which is still from a while ago. Like, yeah, there hasn't been an episode for a while, and I really hope they do more because I miss it. Yeah. Actually, I should hassle them and see if they are going to be doing some more. So, Pick Place podcast. If you are interested in electronics manufacturing, like building boards in quantity, definitely check out Pick Place podcast and Open Hardware Manufacturing podcast. So yeah, two very good resources. Yeah, okay, so Scott says, whenever I do a write-up on my wiki, I start from scratch and follow the process. Then I point a friend who's very good at balking things to try it. Then I rewrite. Yeah, that's a good, yeah. Back in the IVT days, yeah, sorry, mentally stopping myself from going down a particular rabbit hole. Yes. Austin says, it's kind of funny, started a new part-time job for extra cash, and that is one of the things I'm doing, making the user guide for the role. Yeah, so documenting your own role as you go. That's cool. Yeah. Crispian says, I've been in a working environment where this was implemented badly, didn't work. We got blamed for incompetence when the instructions were far from foolproof, especially for an autistic worker. Yes. So okay, there are some nuances around it. You can't just say, we've got docs, therefore any mistakes are your own fault. No. No, 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 no. You can't run the process that way. That is just putting the blame in the wrong place. If you've got docs and someone is trying to follow the docs and they can't do it correctly, it's the docs that are wrong. So, yeah, mostly. I mean, there are always exceptions, but you can't just throw someone at a fixed document and then if things go wrong, say it's their fault. It needs to be much more collaborative than that. The document needs to be updating over time to become more and more clear as time goes on, and to adapt to changes, and also to present information in a way that is easily consumed by its audience. So by the people who are relying on that document, it has to be done in a way that makes sense to them. And if it's not, then it's not good documentation. So, yeah. Jack's Tech said, hire a chaos monkey. Paul Schultz says, did you get to the bottom of the RGB reflow issue? Oh boy, that is a whole thing that I don't... there is more information than since last time I talked to you. Since last time I went to do the... then I need to reset my brain. Hang on, I'm going to take another swig of coffee. Which is totally cold now. Gerald says, blame thinking versus solution thinking. Yep, that's a good way of putting it. Jacksec said, even with docs, it's easy to screw up. Just ask anyone who works in customer-facing roles. Yeah. And RJ suggested, do you include video to show how to do it in the most efficient way? Yeah, potentially. I don't, but that is a way you could do it. I can't actually remember whether Opulo used video for any of their documentation. I think it's just text and photos, but there are certain little things like maybe a calibration process or something that could be good to document as video rather than just as photos. It comes down to how people will best consume it and the clearest way to express what it is you're trying to get across. Now the thing is that video can be very slow. If you are reading through a guide, so if I go to if I come back to this, and I'm just going to go back into the feeder pack out again and back into here. Now, if you had a video that was explaining this, it would probably take, like, even if it was brief, it would probably take 30 seconds to a minute. And it would show, oh yeah, this is how you put the things in the tray, and then this is how you do this. You put these across and lay them on like this, and then you get these, and then you put it in here. And it's very hard to get an overview of a video. When you're watching a video, you are watching a sequence and you are inside the sequence. But with this, with photos, you can just, if you're not clear on a particular part, you just go, oop, oh yeah, where does the tape go? It's there. And you can skim, and and see particular parts of it. So it's usually faster getting information across in photos with a bit of text than it is in a video. But video is also a very good way to supplement this. There may be certain processes where it's easier to show things or explain things on video. And if someone watches a video through once and they get the overall process and then have reference photos for the different stages of the process, that could be a good way to do it. But making a video, it can also be a big burden. It's, yeah. If it's going to be too hard to do, and also it's hard to edit. For example, if you wanted to update part of this guide to make part of it clearer, you can take another photo and substitute it in. But if you've done it all on video, then you've got to make a new video. So, yeah. Anyway, Scott says, any process that can't be clearly explained without video is poorly thought out. Possibly, but I can imagine there are situations where you need context. This is probably more in a software environment. What I find is that when I'm looking at documentation, I've noticed this with Fusion 360 because I fairly regularly will search for something in Fusion, and the way, if you are dealing with a GUI and you're explaining how to get to something, like you were saying, go to this menu and then click on this, and the path can sometimes be hard to convey in just text. So having like some video where you click on this and then this submenu and then this pops out and you do this. Sometimes the fastest way to show that is a video, or essentially a screen capture. So it might be like it could be even like a 5 or 10 second screen capture of click on this menu, go through this option, and this is where you find this particular configuration. And trying to describe how to get to it without the video or without a series of photos, which is essentially just like stills out of it, can be awkward. So there are certain situations where video can be helpful, but it is a heavyweight, hard to produce and inflexible sort of way of representing things. So this sort of process with a sequence of photos, a little bit of text to explain along the way, that is the way I like to do things. Austin said, can't forget that often old guides that are in video format tend to get boosted by search algorithms, which makes it hard to find new stuff. Okay. So all right, so I think, Austin, I think what you're saying is a guide that is outdated and is in video and is hanging around might appear in search results before a more modern, updated version, which is not video. Something like that. Oh, I don't know. Oh, something flying around my face. A little critter. Ah. I got a lot of those around here now. Now that I've got plants and things all through the office, I've got lots of little flying things. Yeah, as John said, many would be lost without YouTube as an educator. Yeah, so much stuff. I've noticed, I think this is partly a generational thing as well, because so my son Tom uses YouTube to figure out how to do lots of car related things. If he wants to change something, like working on the transmission or doing, fixing something in his car, he goes to YouTube and then he finds someone that's got like a 10-minute video showing how something is done, and he'll scrub through it. So what he does is, or one thing I've noticed a lot of people do, is they won't sit there and watch the video from beginning to end. They will scrub and go, oh yeah, that part of the process, which is exactly what I'm talking about with scrolling through here to get to the part that you're interested in. I tend to do it more naturally with things like a series of photos, but the younger generation seem to be quite comfortable with consuming this sort of thing in video format and just scrubbing through the video, and they miss most of the video. They only look at little snippets out of it. It's like, oh, I want to see where he's bolting on this bracket, so they'll scrub through and find the bracket and where the bolts are, and miss all of the context. So anyway, different ways of consuming content. Stephen said there's more money in video guides than text guides, even if a text guide would do a job better. Yeah. Crispian said Jono's attention span is flying around his lab. Yeah. Okay, so Austin was just clarifying my understanding of what he said. Correct, because often the video had become popular, and being high on the search results, it often gets continued to be clocked even when outdated. Yeah, okay. So it becomes self-perpetuating, where a guide that is popular has lots of views, therefore it comes up higher in search results, and therefore it just perpetuates, and something that is newer may not replace it. Simon's comment was, need insect dissipative spray. Yeah, I don't mind them. They're only a couple of little midgy things that fly around and wander around the place. Yesterday my sister gave me some more plants in a little jar, because now that she knows that I am actively trying to put more greenery into the factory, she's given me several things. I've got like a little terrarium full of plants just to my left on the desk. Yesterday she gave me a glass jar which has got stones in the bottom and plants in it to go somewhere. I'll find somewhere to put that. And last weekend also I bought some more plants to stick on the green wall out in the factory area. John said it's called cleanish for a reason. Yeah, the cleanish room is through the glass wall. So the whole idea is the greenery and the day-to-day stuff is in this room. There's a big glass wall, and on the other side of that glass wall, it's all white and clean and pristine. Yep. Okay, so Austin said, actually had it happen recently with a dev board. An external programming port had the ground removed from it, but the documentation that came up didn't reflect it. It took a while before I figured it out. Oh, so it was a missing ground. Also, I've just been printing some stuff. I already showed you, and I'm going to switch over to the overhead view. Here we go. So this is the air quality sensor, which you would have seen last time. This is the new one, fully assembled in the yellow enclosure. I really like this color. This filament, it's not like a, here's a post-it note. So it's not like a washed out yellow. It's a really rich sort of eggy sort of yellow, and I like it. Oh, there's a, that's slightly more washed out as well. It's got a touch more warmth to it. So this filament is the one that I've been using for making the trays that come out of the reflow oven. So reflowed trays go into this yellow, reflowed boards go into trays in this yellow color. I also got some orange filament. It's like a, what do they call it? Pumpkin orange. And I can't decide if I love this or hate it. I don't know. So I had thought that I would use the orange as the color for stuff that comes out of reflow, which is why I ordered it. But I ended up doing the reflow trays in yellow instead. And this one, yeah, I don't know. So I printed an enclosure. Oh, you can see it. I didn't have the text on this one, but I've modified the thing to do multicolor printing. So I've got the buttons. There's no guts in this one yet. Oh, hang on. I have guts here. I have a, yeah, I could just drop, I'm not going to screw it in. I could drop this in. Is it going to fit? Drop that in, chuck that on. Yeah, I could just screw it closed and it's done. So that is the air quality sensor, the mode button, which you can access. You can hear the clicking through the back. The reset is the one with the shorter stalk on it, so you can't press that with your finger, but if you've got anything like a pen or whatever, you can press that one. It comes up to just behind the face of the back cover, whereas this one protrudes about 1 millimeter through the cover. So this one you can get to with your finger, the reset button you can't, but I think that's okay. And the USB-C connector sticks out a little bit, which is unfortunate. It'd be nice if it ended flush with the enclosure, but the only way I could do that is just to make the enclosure deeper, which is kind of valid. I could do that, but it seems unnecessary to make the enclosure deeper just for one connector when everything else is well within the enclosure. It's just USB-C vertical connectors tend to stick up a fair bit. Yeah, so anyway, that is, yeah, I did this after the last stream. I modified the design to add the text onto it. So I'm going to print some in a few different colors just for the fun of it. And I've got to post one to Austin as an appreciation for all of Austin's hard work on the firmware that runs this. So if I, where is it? If I plug this in, I think, did I flash this one? I'm about to find out. Does it come up with anything? Yes! Here we go. So the camera is out of focus because the focus is down on bench height and this won't sit down. So that is running Austin's firmware, and I assembled 4 of them. I've got these 2 that are assembled now, and I have these 2 that just need to go into enclosures, and these do have the firmware on them as well. I flashed them all. So anyway, yet another one of the tasks is to take photos of these and to list them on the on my site. So if anybody is foolish enough to want to buy one, they can. I'm only going to make a few of them. The total worldwide market for these is like 3 people. So I'm not going to bother making any more unless it turns out that people do actually want to order them. And also, I'm not going to... Okay, so this is a slightly, I was going to say philosophical thing. Not really a philosophical thing. It's more just a business decision thing. In the past, I have cared a lot about doing things cheaply, making things at what I consider to be a reasonable price, and I have done that to my own detriment. Like, I will look at the bill of materials and I'll say, oh yeah, there's 20 bucks worth of parts in this, therefore it should be sold for $30. No! Okay, one thing that you have probably noticed if you have gone to the Superhouse site is that most stuff is out of stock. And that is because I have priced things at a point where I just can't be bothered making them. Like, it is not worth my time to spend hours assembling boards when I'm going to make like 10 bucks on them. It's like, why do I even bother? I've got better things to do with my time. So what I'm probably going to do is just put a ridiculous price on this. Like a blatantly stupid price, like $90 or something. And if people buy them, they buy them. And if they don't, that's fine by me. Because it would take me hours to build and assemble just a few of these, and the amount that I would make out of it is way less than if I was just charging contracting rates to one of my clients. So yeah, I'm just going to assemble these 4. I'm going to send one to Austin and put a couple up in stock at with some don't buy me price on it. And if people are foolish enough to buy them anyway, well, yeah, that's just the way it is. Stephen W says if it's 20 bucks a parts, it should be about 50 bucks. Yeah. Mitch says pricing of a product should include get out of bed component. Yeah. Scott says absolute minimum starting point should be BOM cost by 2. Yeah, actually way more than that. It should be, what's the figure? This is a complicated subject, and this is something that is worth talking about in detail. Product pricing, I've talked about it in the past. Product pricing is a very complicated thing. There was an article many, many years ago. I think it was, it might have been Nathan Seidel from SparkFun, or someone who wrote an article about product pricing, and they came up with a number. No, I don't think it was Nathan. I can't remember who it was. Anyway, someone came up with a number which was something like 2.7 times BOM. So if you work out that your bill of materials is $10, then you need to multiply by 2.7, so $27 is a reasonable price to be selling it at. Now, obviously, there are a huge number of factors that come into this. Like, you might have a lot of, like your BOM. Okay, so your BOM may or may not include packaging. If you are putting it inside an expensive box, like a retail box, then you need to account for that. And maybe your bill of materials is including your packing, yeah, all of the retail packaging. But the trap that people fall into is the bill of materials they consider to be just the parts that are on the circuit board. And if you look at that, you are excluding a whole lot of other overheads that you've got to factor into it. So, yeah. Austin says, yep, the more I do stuff for my business, the harder I learn it can be to quote stuff. It's also why I'm particular with who I do work for, as I've gotten far better at not accepting penny pinching. Yeah, that's good, Austin. I'm glad that you're doing better with that. Jack Stick said, in the US that makes sense, 3x in Oz because of shipping. Espero Kelly says, shipping price? Not sure what that is. Stephen says, if a large part of the time cost is the printing of the case, offer the board and a print your own case option. Yep. And John says, I have customers that would not buy an item that appears to be too cheap. That is true. Yeah. So there is perceived value. Hang on, I'm going to switch back over because I'm looking at those comments from a distance. I'm going to switch back over to my computer. RJ said, ask people to pre-order. Once the threshold is reached, you will make a small batch. That's how we fast track projects. Yeah, kind of like a DIY Kickstarter. That's an interesting approach as well. That's could be kind of tricky to handle, because do you take the money up front? And if you do take the money up front, then you are committed to it. And if you don't, then go ahead, you have to refund the money, like if you don't get your target. But you basically have to build a Kickstarter equivalent, or just use Kickstarter. And Espero says, what about the price of putting them in production or having them made in bulk for sale? Yes. And the other thing is opportunity cost. If you're spending time, if I spend an afternoon building a batch of air quality sensors, that's an afternoon that I'm not doing other things, which could be improving the process or building customer boards or working on a different project or whatever. So I've got to be cautious about that as well. Austin says, in actuality, the case is probably one of the cheaper BOM items compared to the electronics, and the case gives the item a far better presentation. Yes, yes. Something that I have seen, Sion, Unexpected Maker, do very, very well with many of his projects is incorporate 3D printing and nice enclosures so that when you get the end result, it feels like you've got a product. There is a big difference between getting a bare PCB and getting a PCB in an enclosure. That enclosure might have 50 cents worth of plastic in it and half an hour of time on the printer or an hour on the printer or whatever. But the difference between getting it as a product versus getting it as a bare board is immense. The perceived value of the thing. And yeah, so Sion does a great job of taking his designs and going that step beyond the dev board experience into something that is like a product. And with the Squixel recently, that was really apparent. The thought and effort that went into the design of the enclosure for that. Just, it turns it from a dev board that you would play with on a workbench to a thing that you would put on a desk or on a mantelpiece, and it doesn't look out of place. It looks like a finished product. So that it, yeah. And that's the case with this. Like, this device, you could stick it on a mantelpiece and it looks like a retail product. It's really cool. And there's a few grams of plastic and a little bit of printing. And it's the difference between this, which looks like a science project, and this, which looks like a product. So I absolutely agree that that a very important part of it is the enclosure, and it really is not a huge beyond the design. So you've got to do the design of the enclosure, but beyond that, if you've got a printer and it's got idle time, hit print a few cases. It doesn't take any of your own time. Then you just grab them and stick the thing in the enclosure, and yeah, you're done. Oh, Scott says, I still think running the USB out the bottom and specifying a right angle cable would be better. It could be. Yeah, it could be. It might be neater. RJ says, we trigger our project whenever 10 or more, which is $5,000 total value, are willing. Then we send out links to prepay, then go ahead. Has worked well for us. Cool. So that means you are dealing with a $500 product. I'm interested to know what the product is and what sort of market it is. Because the audience that you have, if for example it's a specialist item and people are willing to wait for it, so if you are providing something that there is no obvious, oh, I'm just going to go and buy that from somewhere else alternative, then that model could work really well. Like, okay, hypothetically, imagine you are selling a $500 piece of test gear, and the at $500 it's very good value, and people are willing to wait for it, and they say, okay, there is a new batch of this new piece of test gear coming up. It's going to be, I'm going to opt into pre-purchasing this, and then when they hit their number, they're going to make a batch, and I'm going to get one. That would be a really good thing. That's for that particular model or that particular market, that can work very well. But if you are selling something at a lower value, dealing with a larger number of people, so spreading across, you might need 100 people to opt in, then managing the process becomes an overhead. And so, yeah. RJ says, automotive related accessory. Nice. Yeah, that's cool. Austin says, the firmware totally helps with being mantle worthiness. Yeah, yes, it does. Yeah. So Esbro said, I had an art teacher back in the day in junior college that told us, with my sickness, it's important you tell me when you're sick. Never told us what sickness, but these would probably help him. Oh, okay. So this is talking about air quality sensing and things. Yeah. Maybe he had something that that was affected by it. Oh, okay. Gerald said, Chris Greening posted a breakdown of his pricing and profit on his ESP32 Rainbow board because someone questioned the price. Bottom line was way less than his consulting rates. That is really interesting. I am typing that up right now. Chris Greening Rainbow board. Was it worth it? Is this the thing you're talking about? Yeah, this ESP Spectrum is really cool. Was it worth it? Discover more from Atomic 14. Ooh, this. Yeah, okay, Gerald, thank you very much. Yeah, I'm familiar with the ESP Spectrum. Like, I've seen this before, but I had not seen this post, and this looks really interesting. Pricing fundamentals. Oh yeah, it's talking about Dave, economics of selling your hardware project. Yep. So COGS. Oh yeah. Rule of thumb, should be charging a minimum of 2.5 times the cost of the COGS. So cost of goods sold. Yep. Top-down pricing, project timeline, campaign revenue, grad supply fees, cost of goods sold, breakdown, gross profit, labor cost. Yeah, this looks interesting. Why I priced it at this. I am not going to go through all of this on the stream right now, but oh, and it goes on and on. Oh, this is good. Okay, I am going to read this entire article. That looks very worthwhile. I'm going to drop this into the chat as well. So that is the link to Chris's analysis of the economics of his crowdfunding project for the ESP32 Rainbow. Yeah. Grant says, I worked for many years on manufacturing software. COGS includes labor and overheads, not just BOM. Yeah, so complete cost of goods sold is everything that it costs to make the thing, including staff time, etc., etc. Oh, yes. Oh, Mitch said, I wonder if there's a vertical USB socket where the barrel pokes through a slot in the board and the pins are on the other side. Ah, like a reverse mount socket, so it'll be lower profile. I actually can't do it in this situation because it's a surface mount vertical USB socket with 4 stakes, but the other side of the board has the particulate matter sensor flush against the PCB. So I can't have anything protrude through on the other side. And in fact, when I solder those connectors on, I won't bother showing you now. When I solder the connectors on, I make sure that the solder doesn't bulge out too much from those pads because it will stop the blue box of the sensor pushing flat against the PCB. So yeah, a reverse mount USB connector is a really interesting idea, but I couldn't make it fit in that location. I'd need to, maybe it could work if I moved it sideways or something, but there's, yeah. If anyone knows about one of those, that would be interesting. Austin says, oh, yes. Austin said, looks like you might be able to test your modules, plus ideas on hardware revisions. Yeah, so I won't get into this right now, but Rob Tillart has been doing some work on the firmware for the Testomatic modules. I think maybe next live stream, I want to do some Testomatic progress. So, yeah. Where are we? This. Oh yeah, so this was Rob working on testing with things, and yeah, okay, I've got to follow this up. I haven't actually followed that up. I sent Rob some hardware and he has now done a bunch of things on it, so I need to do that. All right, but anyway, I am going to go and get some breakfast / lunch and stop wasting your Sunday morning with my random thoughts, stream of consciousness. I need to actually get some stuff done. I'm so far behind. And yeah, so thank you very much for coming along to the Random Squirrel Emporium and House of Coffee. And next week, I want to do Testomatic. I want to look at Rob's work on the drivers for that I/O chip and actually get the new Testomatic up and running. So, thank you very much for coming along, and I will see you all really soon. Now, go and build something awesome. Thank you. Bye.